Welcome back to Vintage Radio Extra number 5. As you see here, I have begun part 2 by cropping wires etc. away from this B8A valve base. The task of liberating it from this chassis will be straightforward when I apply a drill to its 2 rivets. There we go. Totally bereft of its B8A valve base, and here is the replacement B9A valve base. B9A valve base fitted onto the chassis, and the audio output transformer terminals cleaned up, ready for these wires to be connected onto them. Now, before I begin connecting wires and components etc., I produced, just before filming part 2, this circuit diagram of this radio's audio output pentode EL41 circuitry. As you will observe, it is a no-frills type of circuit. Since I have no circuit diagram for this radio, and it is looking doubtful I'll ever locate one, doing this type of operation, known as reverse engineering, is necessary, as you will observe shortly. So, based upon an audio output pentode PL84 circuit for a television audio output, of which I'm unable to remember at present, I have adapted it for an EL84, which is not difficult to do. PL84 have 15 volt heaters and EL84 have 6.3 volt heaters. Now, you may ask, why did I use this circuit diagram? My answer is, there is no point in reinventing the wheel, so to speak. What you see here is my proposed audio output circuit I'll use in this radio. At present I am unsure about the value of the HT feed resistor, but taking into account this radio's original audio output circuitry diagram I produced, I have a shrewd idea what value it is likely to be. Having not plugged this radio in to the main supply for over a quarter of a century, I don't know for certain the voltage potential coming out of the cathode of the EZ40 rectifier valve. What's more, I don't know the amount of milliamperes that are being drawn. The original audio output and smoothing choke transformer has 2 1.2k 1 watt resistors in series in there, and out of there. Total being 2.4k at 0.5 of a watt. Along with past experience and the 2 1k resistors, I on a 265 to 270 volt DC supply at between 20 and 25 milliamps. From what I've calculated just here, I'd say 20 milliamps is rather low, and 25 milliamps may be on the high side, as I'm wanting to achieve an HT rail of between 202 to 208 volts DC. Therefore, I'll solder in a 2.7k carbon resistor at around 2 watts. Here I've made it a little clearer how I arrived at a value of 2.7k resistance. given all what I've just been talking about, here is my drawing of the original circuit diagram, here on the left, belonging to this radio, and the circuit diagram I have drawn on the right is the EL84 circuit diagram I will be working to. So, on with soldering wires and components. When installing and wiring in a valve base, I get the easier terminals soldered first. This valve base, holding an EL84 valve, pins 4 and 5, the heaters, were soldered first, followed by pin 7, that being the anode. Again, taking my EL84 audio output pentode circuit diagram into consideration, connecting this valve base, including connecting this audio output transformer to the circuitry of this radio chassis, is complete. However, the rest of this radio has yet to be connected to the around 205 volt supply. I will show you what I mean. I appear to have run out of 2.7k 1 watt carbon resistors. I have 3 to 4 dozen of these 2.2k 1 watt resistors for the purpose of what I will be using a 2.7k resistor for. I am not keen on using a 2.2k. So I have decided to use two 5.6k 1 watt carbon resistors in parallel at around plus or minus 10% silver banding. That should present me with a value of between 2.5k through to 3.1k. I'll quickly twist them together and take a value reading. No sooner said than done. The leads of these two 5.6k resistors are being twisted together. And they are presenting me with 2.88k. That will do for me. Those two 5.6k 1 watt carbon resistors soldered onto this tag strip takes care of the HT supply rail. I'm expecting a supply reading to be somewhere between 202 to 208 volts DC. However, I'm not going to run a power test just yet on this radio. That would be unwise, since there are two wax capacitors, Hunt's capacitors, that need replacing. I've already replaced one just here. This one, shielded in copper foil just here, will also be replaced.